Okay, I think we are live. Uh, Hello everyone. I welcome to today's live session. Good to have you here. Um, I hope you're all doing well. Today's session is going to be on a topic quadratic equation. It is going to be a fun session. It is an interesting topic. I like the topic. It is fun to learn as well as fun to teach. So I really encourage you to take the solve all the questions. We will be discussing a lot of concepts today, and make sure to stay around till the end. Okay. So before we move further, let's just talk about the exam itself. IIM Bangalore's newly introduced UG program. So what all programs has IIMB introduced? IIMB was established in 1973. It is an esteemed institute, and it has recently introduced two new programs. The first one is BSc Honors in Economics and BSc Honors in Data Science. In order to be applicable or to apply to this exam, you need to be eligible, and you need to have passed class 12 or equivalent from a recognized board. You need to have mathematics as a subject with at least 60 marks in class 12. So you need to have mathematics as a subject in class 12, and you need to have at least 60 marks in the subject. And you require qualifying the entrance test and the interview. So if you want to take the admission in the institute, you'll have to sit for the entrance test and you'll have to qualify the interview. Again, the entrance test is the main point here, because here we are helping you, or we are trying to help you prepare for this entrance test if you really aspire to join IIMB and the new UG courses that IIMB is introducing. And in that regard, we will be doing the QA section of this entrance test. So let's discuss a few things about the entrance test itself. So the first thing that you need to understand is that the test is 120 minutes long, which is, it is a 2-hour long test. So it is a 2-hour long test. The second thing is, it is a computer based test with 60 multiple choice questions. So 60 MCQs are there. Reading comprehension or English comprehension has 15 questions. Quantitative and data interpretation has 30 questions, and logical reasoning has 15 questions. Okay, so 15, 30, 15. Quant section has the most number of questions from quant section, right, in the test. So in negative marking, there's also negative marking. 1/3 deducted for incorrect responses. So you will get 1 mark for correct responses. You will get 1/3 mark deducted for incorrect responses. And lastly, we have new info. Syllabus followed is NCERT 10th, 11th, and 12th. So it is going to be slightly advanced math, very likely. There might be calculus involved. But today we will be doing some of the moderate to hard, not very easy either, but moderate to hard concepts and questions on the topic quadratic equations, which brings us to this. So again, we are providing free mock tests, 5 mock tests we are providing. You can go to cracku.in. So that is our website. You can go to cracku.in, and this is the page that comes in front of you. You can click IPMET and IIMB UG. You can click on IIMB UG study room free and IIMB UG mock test free. So there are two options: study room free and mock test free. So if you click on study room free, there are free material that is available for you because we are just starting out. And IIMB UG mock test, there are 5 mock tests that you can attempt. If you click on the mock tests, it takes you right here. These are the 5 mock tests that you can attempt, and just try to attempt these. I would highly recommend that if you are trying to take the test, if you are registered for the test, you attempt these mock tests. Okay. Then we also have the free course. So if you go here, okay, yeah, study room free. So if you go to the study room, you can see there's a mock tests, there are daily targets, there's a study room, all these things. This is stuff. you can access it and you can sort of learn these concepts. So all of this is available for free at our website, so you can go to cracku.in to access these. Then again, we are also doing YouTube sessions just like this. So this is a session in a series of sessions that we have done. Today is the 2nd of November 2025. The day is Sunday, and the slot is 3 p.m. to 4:30 p.m. We are doing QA class on quadratic equations. Okay, I hope you stay around till the end. So make sure that you don't go away. Solve all the questions we are going to do today. Okay. Also join our WhatsApp channel. So we have a WhatsApp channel. The link is in the description. You can just click on the description and you can join through the link. So okay, before we start with quadratic equations, let's review polynomials. So what exactly are polynomials? A polynomial expression is an expression that can be built from constants and variables or indeterminates. So variables are also known as indeterminates because we don't really know the exact value of the variable. By means of addition, multiplication and exponentiation to a non-negative integer power. The power should be a non-negative integer. The power cannot be a rational number, just any rational number. It has to be an integer. It cannot be an irrational number, and it has to be non-negative. The power cannot be negative, which means the variable cannot be in the denominator, right? Negative powers means that the variable comes out in the denominator. The variable cannot be in the denominator. The highest integer power of a polynomial is called the degree of the polynomial. The highest power, for example, consider this is the standard form of a single degree polynomial. So here we are not single degree but single variable polynomial. So a polynomial can have n number of variables, right? Here we are only taking one variable, which is x. So the standard form turns out to be a n x raised to the power of n, a n minus 1 x raised to the power n minus 1, and this goes on until we get the constant term a0. A0 is the constant term because it does not have any variable attached to it. Here these numbers are constants and they are called coefficients. So an is the coefficient of x raised to the power of n. An minus 2 is the coefficient of x raised to the power n minus 2, and so on. So these are referred to as polynomials. I hope you already understand what a polynomial is. It is a very basic stuff. So before we move ahead, just make sure to sort of remember this, that degree of the polynomial is the highest power of the polynomial. Okay, so in any polynomial, the highest power in that polynomial is referred to as the degree of the polynomial. This brings us to a quadratic polynomial and the general form. So what exactly is a quadratic polynomial? A quadratic polynomial is a special kind of polynomial where the degree is 2. So in a quadratic polynomial, the maximum power of x, the maximum power of the variable turns out to be 2. So the quadratic form polynomial, the form is ax squared plus bx plus c. This is the standard form of a quadratic polynomial. Okay, so I hope that's understood. Let's move ahead to discuss quadratic equations. So this is today's topic. So how is equation different from the polynomial? Well, as you can hear in the name, the polynomial is just a polynomial. It's just an expression. When we are talking about equation, we are actually equating it to some value, right? A quadratic polynomial, which is ax squared plus bx plus c, when equated, when it is put equal to a quadratic or linear or a constant polynomial. So you can put it equal to a another quadratic, because the quadratic will somehow rearrange themselves to give you another quadratic, right? So you can put it in front of a quadratic, like this is a quadratic, and you can equal it to another quadratic. You can also equal it to a linear polynomial where the maximum power is 1, or you can also equal it to a constant polynomial, right? And when you do this, it is referred to as the quadratic equation. Okay, so a quadratic polynomial, when equated to a quadratic, linear or a constant polynomial, is referred to as the quadratic equation. The general form of a quadratic equation requires us to have a modified quadratic equation on one side and 0 on the other, such that ax square plus bx plus c equals 0. So when we are writing the general form of the quadratic equation, it is important that we bring everything to one side so that the other side has just 0. Okay, so one side there should just be ax square plus bx plus c after putting everything on the left hand side or the right hand side, and the other side should have 0 and nothing else. Okay, so this is the standard form of a quadratic equation. Got it? Now let's move ahead to discuss roots of a quadratic equation. Now, when we are talking about roots, the roots of a quadratic equation are the values of the variable x. So remember, the quadratic equation is ax square plus bx plus c equals 0. But if you put any value of x here, does that guarantee that ax square plus bx plus c will give you 0? It's not guaranteed, right? It might give you any value. It is not guaranteed that it will definitely give you 0. But the roots of a quadratic equation are the values of the variable x, where the equation takes the value 0. So this equation will take the value 0 for some value of x, and that value of x will be referred to as the root of the quadratic equation. So when the standard form is satisfied, so this standard form is satisfied. Okay, so this is the standard form of the quadratic equation. When we put x value here such that this form is satisfied, we will say that the quadratic equation is satisfied, and therefore the value of x that we just put in, the value of x is the root of this quadratic equation. So consider alpha and beta. If alpha and beta are the roots of the quadratic equation ax square plus bx plus c equals 0, if there are two roots of the quadratic equation, if the roots are alpha, let me write it here, and beta. If alpha and beta are the two roots of the quadratic equation, then in that case ax square plus bx plus 0, if this is satisfied, if we put x equals alpha and if we put x equals beta, if the equation is satisfied, then we will say that this is the factorization such that either x minus alpha or x minus beta are equal to 0 at the said values. This means that they are factors of the polynomial ax square plus bx plus c on the LHS of the equation. Okay, so alpha x equals alpha is satisfying the equation. X equals beta is also satisfying the equation. So if you put alpha in the equation, the whole equation becomes 0 equals 0. If you put beta, the whole equation again becomes 0 equals 0. Now look at x equals alpha and look at x equals beta. You can put alpha on the left hand side. It will become x minus alpha equals 0. You can put beta on the left hand side. This will become x minus beta equals 0. Now this satisfies this equation, right? This also satisfies this equation. How is this possible? This is only possible when x minus alpha and x minus beta, because 0 is here as well, here as well, here is also 0, here there is also 0. So how can these satisfy this? They can only satisfy if x minus alpha and x minus beta are equal to 0 at the said values. This means that they are factors of the polynomial ax square plus bx plus c. So these are what are called factors. Okay, so ax square plus bx plus c, let me erase this, ax square plus bx plus c, this is the quadratic equation, and this is the quadratic polynomial on the left hand side. This polynomial will have the factors x minus alpha and x minus beta, such that putting these values here will satisfy this equation, right? X minus, and it is to be ensured that x minus alpha is equal to 0 and x minus beta is equal to 0. This has to be the case. And what does this mean? This means that alpha and beta are the roots of the equation. So we can write this equation as a times x minus alpha times x minus beta equals 0. And x minus alpha and x minus beta turn out to be the factors of the polynomial x square plus bx plus c. This brings us to factorizing to find roots of a quadratic equation. Now, how do you find roots of a quadratic equation? If I give you a quadratic equation, and then how do you exactly find roots of it? Okay, so we will continue. Let me just see if you have any queries. Okay, you don't have any queries. A times x minus alpha times x minus beta equals 0, such that either x minus alpha or x minus beta are factors of the polynomial on the LHS of the equation, and simplifying this will give us x square plus bx plus c. Then equating x minus alpha and x minus beta respectively to 0 will give us the two roots alpha and beta. Like essentially need to write this equation in this form. If we write this equation like this, then we can be sure that putting these equal to 0 will give us the two roots alpha and beta, right? Now, again, if you notice here, this gives you this. So, there's something called sum and product of roots that we will come after. So, keep this in mind, that this is the essential form, that these two things are essentially the same. A times x minus alpha times x minus beta equals 0 is the same as ax square plus bx plus c equals 0. Why is it the same? Because alpha and beta are the roots of the equation. So how do you exactly factorize a quadratic equation? So suppose I give you the quadratic equation x square minus 7x plus 12 equals 0. If I give you this equation, how are we supposed to solve it? The method is pretty simple. What we do is this: we first observe the coefficient of x squared. What is the coefficient of x squared? The coefficient of x squared is 1. Then we observe the coefficient of the constant coefficient. The constant coefficient is 12. The constant value, the constant term is 12. What is 12 times 1? So we just first write 1, we write 12. What does this give us? This gives us 12. Now try to find factors of 12, two factors of 12 that multiply to give 12, because again, if you find a pair of factors of 12 that multiply to give 12, such as 6 and 2, so 6 and 2 are factors of 12, they multiply to give 12, but they add to give this number, so they add to give the value of 7. So the first thing that comes to my mind is, I think about it and I like minus 3 and minus 4. If you multiply these two numbers, you have to sort of guess a little. You have to make a guess. If the number is very large, we might use some other method. But if numbers are easy enough to understand, then you might have to take a guess. But essentially, when you see that this is 12, when multiplying this into this gives us 12, then you need to find a pair of numbers that multiplying them gives us 12, but adding them gives us the middle term, which is minus 7. So if you add minus 3 and minus 4, you will get minus 7. If you multiply minus 3 and minus 12, you will get 12. This means instead of writing minus 7, you will try to write x square minus 3x minus 4x. So I have written minus 3 and minus 4 plus 12. So I hope this is visible. Plus 12. So x square minus 3x minus 4x plus 12. Let's continue this here. This is the equation that we are left with. Now consider the first two terms and the last two terms. I can take x common here, I will get x minus 3 inside. Then I can take minus 4 common here, I will get x minus 3 inside. If you multiply this, you will get exactly this. If you expand this, this will come out. This is the same as this. Okay, so I have written this instead of that. Now x minus 3 is here as well as here. I will just write x minus 4 times x minus 3. So I have written the original equation in terms of two factors. So I have written the original equation in terms of two factors. I will just take one factor one by one, each factor one by one. The first factor will give me x minus 4 equals 0, and therefore x equals 4. The second one will give me x minus 3 equals 0, and therefore x equals 3. So the two roots are 4 and 3. 4 and 3 are the roots of the original quadratic equation, right? If you try to solve this quadratic equation, x square minus 7x plus 12. So this was the quadratic equation that we had, x square minus 7x plus 12. If you put the value of x as 3, if you put the value of x as 4, this whole will be equal to 0, because the quadratic equation was factorized as x minus 3 times x minus 4. So this is the essential method that we use to factorize a quadratic equation, and factorizing helps us find the roots of the quadratic equation. Another thing to remember is that in any polynomial, the maximum number of roots that any polynomial can have is equal to the degree of the polynomial. Again, if there is a cubic equation or a cubic polynomial which has the degree 3, the highest degree is 3 in a cubic polynomial, then the total number of possible roots is 3, right? They might be real, they might not be real, they might be imaginary. So they might be real or imaginary, but the total number of roots in a cubic polynomial is 3. Similarly, in an n degree polynomial, the total number of possible roots are n. In a quadratic polynomial or in a quadratic equation, the total number of possible roots are 2. Okay, because the degree of a quadratic equation is, or a quadratic polynomial is 2. Okay, so just try to solve this question. I'll give you some time. I'll give you 1 minute for this. Shouldn't be very hard. Try to solve this. Okay, 5 seconds left. I hope you have solved this, and that's it. Time is over. So we need to factorize 6x squared plus 11x plus 3. Remember what I told? We'll just take the constant term and we'll take the coefficient of x squared, which is 6. So 6 is the number, and the constant term is the number. So you just multiply them, we'll get 6 times 3 equals 18. Right? Now we'll factorize 18. What are the factors of 18? The factors of 18 are 2 9s are 18, 3 3s are 9, 3 1s are 3. If you notice, 2 and 3 3s are 9. When we add 2 and 9, we'll get 11. So 2 plus 9 is equal to 11. This means that 6x square, 11x can be written as 2x plus 9x, where 2 times 9 is equal to 18, which is 3 times 6, right? Plus 3 equals 0. Now here I can take 2x common, right? So 2x I will write here, and inside I will have 3x plus 1, right? And here I can take 3 common, and inside I will again have 3x plus 1. This is the magic of factorization. Inside this term becomes the same. So both here as well as here the term is the same. This means I can further do 2x plus 3 in one bracket, and in the other bracket I will have 3x plus 1, and this is equal to 0, right? So again I have factorized this. This is all I needed to do. If I want to find the roots of this equation, I'll essentially get this equals to 0 and this equals to 0, which means x equals minus 3 by 2 and x equals minus 1 by 3 will be the roots. But here I just need to factorize, and the correct answer is option A, 2x plus 3 times 3x plus 1. Here, if you want an alternate method, if you don't know how to factorize, you can just multiply them as well. If this multiplied gives you this, and this is the correct answer. Others will not give you this. Okay, and that's it. As simple as that. sum and product of the roots of a quadratic equation. Now this is a very important concept. I asked you to remember this. I told you that a times x minus alpha times x minus beta equals 0. This is how we write a quadratic equation when we factorize it. So after we are done factorizing it, this is how we write it. Now if I try to multiply the brackets and write everything in detail, I will essentially get a times x squared, x times x is x squared, then x times beta or minus beta is minus beta x times alpha is minus alpha x, and alpha times beta is alpha beta plus sign because both are in minus. This will give me 0, right? I can again multiply by a, I will get x squared minus alpha plus beta x times a plus a times alpha beta equals 0, and here this should be ax squared. Now if you notice, this should be equal to what? This should be equal to what? This should be equal to our original quadratic equation. Our original quadratic equation was ax square plus bx plus c equals 0. This was the original quadratic equation. These both should be the same, and we know that they are the same. Why? Because x minus alpha and x minus beta are the factors of this quadratic. So they are both the same, and therefore we can see that a is equal to a, x square is equal to x square, and therefore this should be equal to this. So a times alpha plus beta minus a times alpha plus beta should be equal to b, right? And a times alpha beta should be equal to c. What does this mean? This means that alpha plus beta comes out to be minus b upon a. You just need to divide this by minus a on both sides. And this means that alpha beta, which is the product, comes out to be c upon a. So these are what are called the sum and product of the roots of the quadratic equation. So if you have the quadratic equation this, x square plus bx plus c equals 0, everything is simplified. You have written all the quadratic equation on the left hand side, and on the right hand side you only have 0. If this is how you have written already the quadratic equation, then the sum of the roots becomes minus b upon a. The product of the roots becomes c upon a. So this is what you need to remember, because these come very handy. These are very useful in finding the answers to many of the questions. So based on this, I will give you a tricky question. It is a slightly lengthier one. I'll give you 2 minutes for it. Try to solve the question. Okay. So here's your question. Try to solve it. I'll give you some more time. Okay, I think that is enough time for you to solve this question. If you have not solved the questions, continue solving it to get the answer. I hope you have written down the question. Other than that, let's try to solve this. So we have this quadratic equation, Lx square plus mx plus n equals 0. This is the quadratic equation that we have. Now what do we know about the sum and the product of the equation? We need to first calculate the sum and the product of the equation. So let's assume the zeros as alpha and beta, which we have already been given, right? We know that the zeros have to be alpha and beta. Alpha and beta are the roots of the equation. This means that alpha plus beta, which is the sum of the roots of the equation, has to be equal to minus m upon n minus b upon a. Sum of the roots is equal to minus b upon a. Here b is equal to m, a is equal to l. So the sum of the roots becomes minus b, which is minus m over l. And the product of the root becomes n over l. Okay. So the product of the roots, which is alpha beta, is n over l. Now there is another quadratic. This new quadratic is what we need to find. Okay, this new quadratic has these roots. The first root is alpha square plus 1 over beta. The second root is beta square plus 1 over alpha. Okay, now this root, if these are the equations, we can also find the sum and the product of these roots. So what is the sum of these roots? The sum of these roots will be alpha square plus 1 over beta plus beta squared plus 1 over alpha, right? This simplifies to alpha square plus beta square plus 1 over alpha plus 1 over beta, right? We can write this alpha square plus beta square. What can we write? We can write alpha plus beta whole square, but we need to subtract 2 alpha beta. Alpha plus beta square, alpha square plus beta square, we can write alpha plus beta ka whole square minus 2 alpha beta. Why? Because we know that x plus y whole squared, m plus n or x plus y, what should I choose? I should choose c and d. So c plus d whole squared is equal to c squared plus d squared plus 2cd. Therefore, c square plus d square is equal to c plus d square whole squared minus 2cd. So instead of writing this, I have written a plus b whole squared minus 2a alpha beta. Plus, now this simplifies to what? I can write alpha beta in the denominator, and in the numerator I will have alpha plus beta, right? This simplifies to this. I just need to put the values. That's it. What is alpha plus beta? Alpha plus beta is minus m over l. So I will write minus m over l whole squared minus, what is 2 alpha beta? 2 alpha beta will be 2 times n over l. So this will be 2nl, 2n over l, plus what is alpha plus beta? Again, it is minus m over l. What is alpha beta? It is n over l. Okay. Now this simplifies to, I can cancel L and L. I'll get m square over L square minus 2n over L plus minus m over n. I can take the LCM. Here I will get L squared n. This comes out to be m squared n minus, this comes out to be ln, so 2ln squared minus n and n, so this comes out to be L squared m. Okay, this is the sum of the roots of the new quadratic equation. The new quadratic equation, which has the roots alpha square plus 1 over beta and beta square plus 1 over alpha. So these new roots have the sum this. This is the sum. What about the product? What about the product? So let's calculate the product here. The first one is alpha square plus 1 over beta. The second one is alpha square plus 1 over, or not alpha square, beta square plus 1 over alpha. I can multiply this. I will get alpha square beta squared plus 1 alpha square times 1 over alpha, which is just alpha, beta square times 1 over beta, which is just beta, and 1 over beta and 1 over alpha, this is just 1 over alpha beta. This will give us, now what is this? This is nothing but alpha beta whole square, plus this is just alpha plus beta, and this is 1 over alpha beta. Now we know the values of alpha plus beta and alpha beta. These, I hope this is visible. Okay. Now alpha beta is n over L. So this is n over L squared, plus alpha plus beta is minus m over L, plus 1 over alpha beta is 1 over n over L, which is the reciprocal of n over L. So this will be L over n. Now let's solve this. This is nothing but n square over L squared. So I'll just simplify this by writing this. I'll get in the LCM L square n. In the numerator, I'll get n cubed. Here I'll get L divided by L square n, which is, or L square n divided by L, which is Ln. So this is Lmn times this, right? Plus n divide L square n divided by n, which is just L square. So this is L cubed. This is the product of the roots. Now this is the sum of the roots. This is the product of the roots. We just discussed, right? We just discussed this. That for any quadratic equation ax square plus bx plus c, b is nothing but I can write this instead as x squared plus a times alpha plus beta, not plus, minus a times alpha plus beta x plus c times, which is just alpha beta. So a times alpha beta, right? This is how I can write this equation, where alpha plus beta is the sum of the roots, alpha beta is the product of the roots. Now here's what you have to assume, right? You have to assume that the value of a is 1. You have to assume for a while, or you have to say that we don't know the value of a. We don't know the coefficient of x squared. We don't know about the coefficient of x squared. But we know that the alpha plus beta, which is not the actual alpha beta, but here the alpha dash and beta dash I should write, because alpha beta, the values are already given. The question itself uses these terms. Okay, so here I can just write ax squared minus a times, what is alpha plus beta, which is the sum of the roots. The sum of the roots, the new one that we calculated is this. This is m square n minus 2ln squared minus L squared m divided by L squared n, right? Plus a times alpha times beta, the new product. The new product is this, n cube minus lmn plus L cube upon L square n. So this is n cube minus lmn plus L cube over L squared n. So this is the new equation, ax squared minus a times this minus plus a times that. We don't know the value of a. We don't know the value of a. But here we have calculated our answer. This is our answer. Here we need to match if something matches here. So here if you see L squared n, L squared n, L squared n. So they are assuming the value of a as L squared n. So let's assume the value of a as L squared n. Put a equals L squared n. If you put L squared n here, you will get L squared n minus L squared n and L squared n will cancel out. This will be m squared n minus 2ln squared minus L squared m x. There should be x here, right? Plus again L squared n and L squared n will cancel out. This will be n square minus lmn plus L cube, or n cube and L cube. Okay, so this is the answer. This is the true answer. Okay, let's try to match L square n, L square n, L square n. Okay, what else? M square n, 2ln square, L square n. M square n, no, M square n, this one. N cube, lmn, L cube. N cube minus lmn, L cube. Right? So the correct answer is option C. If you have any doubts, just post them in the chat box. Okay. Okay, let's move ahead. Again, to remind you, we are providing you with 5 free mocks. Just go to the website cracku.in/IIM Bangalore UG mock test and attempt these mock tests. Okay, these will be very helpful. Next, graphic interpretation of a quadratic function. This is very important, right? A lot of questions come from this. So take the quadratic function. Now, since quadratic is actually a polynomial, right? The essential form of the quadratic is a polynomial form, ax squared plus bx plus c. It is a polynomial. The degree is 2. Fx equals x squared plus c. If you define the polynomial, the function fx such that fx equals x squared plus c for some constants a, b, and c. So we can plot it on the graph y equals fx. We can plot it on the graph y equals fx. How does it look? So here is the graph. I think it is not loading. Wait, why is it not loading? Okay, wait, let me just reload this. Just a second. Okay, I think just a minute. We'll just connect in a little while. Just wait a minute. 857. Okay. Okay. Yeah. Back live. Okay. So I think we are back. So again, we were discussing the graphic interpretation of a quadratic function. How do we graphically interpret a quadratic function? So here a function y equals fx, where fx is defined as ax squared plus bx plus c, whereas for some constants abc. Again, the same as the quadratic polynomial. So how we graphically interpret it? So what we do is, let me just reverse contrast. Okay. So this is the parabola. Parabola is the essential shape that you get when you graph a quadratic function. When you put a quadratic function on the graphs, this is the shape that you get. If you change the value of a, it has the most effect. Why? Because again, x squared term, the x squared term, which is ax squared plus bx plus c, right here. X squared term is causing the most change because it is raised to the power of 2. So when x changes, when a changes, it causes the most effect. If you change b, all it does is somewhat rotate it. So it just somehow rotates the quadratic function. Here I am changing b. So it just somehow on a constant value around this value right here, 0, 1, it is rotating it somewhat, right, around that value. If you change the value of c, all that happens is quadratic equations goes up or down. If you increase the value of c, it will go up, while if you decrease it, it will go downwards. So we will discuss this further when we are talking about the quadratic formula and the discriminant. But here the graph is very important because it helps us solve multiple questions, especially when it comes to questions regarding range and so on. Okay, completing the square. So here's another method to find the roots of the quadratic. How do we exactly go about completing the square? It's a very simple method, right? Consider the quadratic equation ax squared plus bx plus c equals 0. What we will do is we will divide the whole equation by a. So this will be x squared plus b upon a x plus c upon a equals 0. Okay, this is the equation that we will get when we divide the whole equation by a. Now let's move c over a to the right hand side. X square plus b over a x plus c over a equals 0. Okay, this is I should have moved this to the, okay, this is what we get. We moved c over a to the right hand side. Now let's add b over 2a squared. So b over 2a whole squared will add to both the left hand side as well as the right hand side, right? So what we will get is x squared plus b over a x plus b over 2a whole squared equals b over 2a whole squared minus c over a, right? This is what we get. We can go further. We can write this as x squared plus b over a x plus b squared over 4a squared equals b squared over 4a squared minus c over a. Now this left hand side, if you see, we can essentially write this as x plus b over 2a whole squared, because when we expand this, we will get x squared plus b over 2a whole squared plus 2 times b over 2a times x, which is b over a x. This is equal to b square. We can take the LCM as 4a squared. We'll get b squared minus 4a squared divided by a is 4ac, right? Then we can take the square root, right? If we take the square root on both sides, we'll get b over 2a plus minus the square root of this, b square minus 4ac divided by 4a squared, because both the plus sign and the minus sign will satisfy this. Both the plus sign and minus sign will satisfy this. We can move further. We'll get x, essentially x equals, now we can move b over 2a to the left hand side. We'll get minus b over 2a plus minus square root of b square minus 4ac divided by 4a square, right? X equals, now 4a squared, the square root, when we put square root on a whole fraction, right, it is put on the numerator as well as on the denominator. So we'll take the square root of the denominator. We'll get minus b over 2a plus minus divide by 2a, the square root of b squared minus 4ac. So x equals, the LCM comes out to be 2a, minus b remains that, plus minus remains there, and this will be b square minus 4ac. So these are the two values of x that we got. The first value will be minus b plus b square minus 4ac square root over 2a. The second value will be minus b square minus 4ac upon 2a. So these are the two values that we have of x. Now how do you apply completing the square method on a given equation? So remember the example that we did earlier, that we found the roots to be 4 and 3. That example was x square minus 7x plus 12 equals 0. X square minus 7x plus 12 equals 0 was the example. Now what we can do is we can apply the completing the square method on this. How? We'll just first divide it by a. A is just 1, so that doesn't really make a difference. We have just divided by a. Okay, then after what we do, we put the c on the right hand side. So we just do x square minus 7x plus 12 or equals minus 12, right? Now what we do, we add on the right hand side as well as on the left hand side b over 2a whole square, right? So this will be b. What is b? B is minus 7 over what is a? A is 1. So b over 2a will be minus 7 over 1 whole squared, which is 49. Minus 7 whole squared is 49. So this comes out to be x squared minus 7x plus 49 equals minus 12 plus 49. So we have added 49 both to the left hand side as well as to the right hand side. Now what is this? This is nothing but x minus 7 whole squared, right? This is nothing but x minus 7 whole squared. And what is this? This is 7, 4 minus 1 is 3, right? 9 minus 2 is 7 and 4 minus 1 is 3. Why is this not giving us an integer? Wait, b over 2a. Oh, so this should be 2a. Oh, my bad. This should be 2 times a, which is 2. So we'll add 7 by 2 whole squared, which is 3.5 whole squared, which is 49 by 4. So we'll just add 49 by 4, not 49. Okay, this is what we will add. Now we can complete the square. We'll get x minus this is 7 by 2 whole squared is equal to 49 by 4 minus 12, which is 12 is nothing but 48 by 4, right? So 49 by 4 minus 48 by 4 is 1 by 4. This gives us x minus 7 over 2 equals plus minus 1 over 2, because the square root of this is 1 over 2, which means x is equal to 7 over 2 plus minus 1 over 2. This means x is equal to either 8 over 2 or 6 over 2. This gives us 4 and this gives us 3. So the two values are 4 and 3. X square minus 7x plus 12, the two values are 4 and 3. Okay, so this is how we apply the completing the square method, my bad, to any quadratic equation, right? But if you notice here on the right hand side, this, what exactly is this? This is x equals minus b plus minus b square minus 4ac square root over 2a. What exactly is this? This is known as the quadratic formula, because you don't need to do all of this. You don't need to actually go about this whole process of adding or multiplying minus b over 2a on both sides and so on. You can just apply this formula and get the same answer, which brings us to the quadratic formula. So this is known as the quadratic formula. Whenever you have ax squared plus bx plus c equals 0, which is a quadratic equation, you can apply this formula to find the roots of this quadratic equation. It will give you a roots directly without you having to do anything. Okay. This is another question. You can use the quadratic formula to find the roots here. I'll turn on the timer. You have 2 minutes. Before I turn on the timer, let me just write the formula here. This is minus b plus minus b squared minus 4ac over 2a. This is the formula you have to use. Okay, the time starts now. So if you have any doubts, you can post them in the chat box. I will try to answer them. Okay. Okay, 5 seconds left. And the time's up. So you have two equations, right? The first equation is 2x square minus 7x plus 3. The second one is 4y square plus 3y minus 1. And you have to apply this formula. I am saying you have to apply, you can solve however you want. But just because we discussed this formula right now, it's better that you practice it if you haven't already. So this is the formula that we have. This is the first equation. Let's say this is the first equation. Let's call this f of not f of x. Let's call this the first one, and let's call this is also already written. Okay, here's the first one. First one gives us the value of x as minus b plus minus b squared minus 4ac divided by 2a. What is b? B is minus 7. So minus of minus 7 is plus 7. So this is 7 plus minus. What is b squared minus 4ac? B squared minus 4ac is 7 squared minus 7 squared, which is 49, minus 4 times a times c, which is 4 times 2 times 3. So 4 times 3 is 12, times 2 is 24, divided by 2a. A is 2, and therefore 2 times 2 is 4. This gives us the two values as, again, what are the two values that it gives us? The first one is 7 plus minus. What is 49 times minus 24? 49 minus 24 is 25, right? And the square root of 25 is 5, divided by 4. This will give us the two values of x as 7 plus 5 divided by 4 and 7 minus 5 divided by 4. This will be 12 by 4, which is 3, and this will be 2 by 4, which is 1 over 2, right? Then the second one will give us x equals this is here, not x, this is y, right? Y 4y squared plus 3y minus 1. Here we have b as 3 and we need minus b, so we'll put minus 3 plus minus. We need b squared, so this is 3 squared, so this is square root of 3 squared, which is 9, minus 4ac, so minus 4 times 4, which is minus 16, minus 16 times minus 1, which is plus 1. So this is plus 16, 9 plus 16, divided by 2a, which is 2 times 4, which is 8, right? This will give us minus 3 plus minus 9 plus 16 is 25. The square root of 25 is 5, divided by 8. So again, we have two roots, minus 3 minus 5 divided by 8 and minus 3 plus 5 divided by 8. So minus 3 minus 5 divided by 8 is nothing but minus 8 divided by 8. Minus 8 divided by 8 is nothing but minus 1. And minus 3 plus 5 is nothing but 2. And 2 divided by 8 is 1 over 4. So x comes out to be 3 and 1 by 2. Y comes out to be minus 1 and 1 by 4. So this is the number line. Consider the number line. This is the number line. Okay. Consider it to be infinite. Okay. Now where is 3? Let's say 3 is here. Where is 1 by 2? 1 by 2 will be here somewhere, right? Then where is 1 by 4? 1 by 4 will be here. And where will be minus 1? Minus 1 will be here. So these both are the values of y. These both are the values of x. So what can we say here from this? We can say that x is always greater than y, right? Because both the values of x are greater than both the values of y. And therefore, the correct answer will be x is greater than y, which is option A. Okay. Pretty fun question to solve, right? You first had to solve two quadratic equations. then you had to actually determine these ranges. The both of these values have to be smaller than or larger than both of these values. Okay, so let's discuss something else. The discriminant of a quadratic equation. So what exactly is a discriminant? Now you remember the quadratic formula, right? We just discussed. This is the quadratic formula. If you look here, square root of b square minus 4ac, this part, the square root part, right here. We know that anything that comes inside the square root has to be a square number, right? That's what it means to be inside the square root. You are a square number, and we want inside as the output, we want a number that gives this as the square. This means b square minus 4ac has to be greater than 0 in order for this to make sense, or greater than or equal to 0 in order for this to make sense, right? Essentially, we have three conditions. The first condition is that b square minus 4ac is, or the two conditions, let's take two conditions. The first condition is b square minus 4ac is greater than or equal to 0. B square minus 4ac is greater than or equal to 0. If this is the condition, then this quadratic formula, there will be some value to this. There will be some value to this part, right? This part right here. This will have some value, some real number value, and therefore the roots will be real. Why? Because these are roots, right? X equals minus b plus minus b square minus 4ac upon 2a. These are roots. This is the value of x. That's what we found. These are roots. So whenever this is greater than or equal to 0, which is the roots, then the roots will be real. Real. And if the b square minus 4ac, which we call the discriminant, is less than 0, then roots are complex or imaginary. Okay, got it? Now we have one more thing here. The another thing is, if b square minus 4ac is greater than or equal to 0, then it can be divided into two parts. The first part is b square minus 4ac is equal to 0. Right? What is the quadratic formula? The quadratic formula says minus b plus minus b square minus 4ac divided by 2a. This is the formula. If b square minus 4ac is equal to 0, just try to put that value here. Okay, what will this give us? This will give us minus b plus minus 0 is square root, which is nothing but 0. This will be minus b over 2a. And voila. This is only one 0. Only one 0 is there, not two zeros. Only one 0 is there. If you look here, b square minus 4ac is greater than 0, then this will give two values, one for minus and one for plus. So here we have two equal roots. This looks like just one root, but this is actually two roots equal, right? Two equal roots, because this is plus minus 0. And this is two distinct roots. Okay. Now, so these are the conditions that you need to remember, that if in order for the roots to be real, you need this greater than or equal to 0. If you don't want them to be real, then this has to be less than 0. Otherwise, if you want them to be real and equal, so these are real, right? Because b square minus 4ac is greater than or equal to 0. These are real. In that case, if it is equal to 0, there are two equal roots. If it is greater than 0, then there are two distinct roots. Alright? Simple enough. Let's move ahead with a question probably. This is not coming. Okay. Try to solve this. Forgot to turn on the timer. Okay, that's it. Okay, I think that should be enough time. I think we lost some time there. So again, we discussed the discriminant, which is denoted as d, to be equal to b square minus 4ac, right? Now x squared plus 6x plus the modulus of r equals 0 has integer roots. How many integer values can r take? Firstly, whenever we are talking about integer roots, the roots are real because integers are real numbers, right? So x squared plus 6x plus modulus of r has integer roots. How many integer values can r take? So firstly, let's just take the modulus of r equals to some number k. Since modulus of r is always positive, k is always greater than or equal to 0. Right. Now let's try to find the roots of this quadratic equation. The roots of this quadratic equation are x equals minus b. Minus b is minus 6 plus minus the square root of b squared, which is 6 squared, which is 36, minus 4ac. A is 1, minus 4 is minus 4, and c is the modulus of r, which we assumed as k, is minus 4k, divided by 2a. So 2a is nothing but 2 times 1, which is 2. Now look at this. X equals minus 6 plus minus, this is 4 times 9, this is 4 times 1, so we can just write 4 outside and we can write 9 times k divided by 2. This will give us x equals minus 6 plus minus, the square root of 4 is 2, so 2 will be outside and we will have 9 minus k here, divided by 2. X equals, we can divide by 2, we will get 2 minus 6 divided by 2, which is minus 3, plus minus 2 divided by 2 is 1, this will be 9 minus k. Now we want the integer root, right? Because this quadratic has integer roots. X square plus 6x plus r has integer roots. So these are both integers. If this is an integer, this is an integer, then this has to be an integer. So 9 minus k is an integer. Okay. If 9 minus k is an integer, or the square root of 9 minus k is an integer, if the square root of 9 minus k is an integer, then 9 minus k is a perfect square. So 9 minus k is a perfect square. Right? So how does perfect square go? We can have 0 squared as 1. We can have 2 squared or 1 squared as 1, or 0 squared as 1, 0 squared as 0. We can have 2 squared as 4. We can have 3 squared as 9. So this can be equal to any of these values. We can't go beyond this because k is a positive number. This has to be less than 9. If k is greater than 0, then minus k is less than 0, right? Then 9 minus k is less than 9. Therefore, this has to be less than 9. So these are the only 4 values that it can take. So if 9 minus k is equal to 0, then k is equal to 9. Okay. If 9 minus k is equal to 1, then k is equal to 8. Okay, these are the values of k. If 9 minus k, and these are the values of 9 minus k right here. So if 9 minus k is equal to 0, k is equal to 9. If 9 minus k is equal to 1, k is equal to 8. If 9 minus k is equal to 4, then k is equal to 5. If 9 minus k is equal to 9, then k is equal to 0. Again, k is equal to modulus of r, right? That's what we assumed, right? K is equal to modulus of r. This means r, the value of r can be plus or minus 9. Here it can be plus or minus 8. Here it can be plus or minus 5. Here it has to be 0. So how many values can r take? R can take plus minus 9, plus minus 8, plus minus 5 and 0, which is 3 to the 6 plus 1, 7 values. So R can take a total of 7 values. Is the answer 0? No. 1? No. 2? No. More than 2. The correct answer is option D. Let's try to do another problem. This is also not loading. Great. Try to do this one. You have 50 seconds for this. Okay, I think it's time. Before this, we should have discussed the minimum value of a quadratic function. We didn't really get the time. So let's discuss this now and then we'll try to solve this question. Okay, we discussed that a quadratic function is like this. It is a parabola. It is a parabola and it looks like this. This is the first root, this is the second root. What is this root? This is say minus b squared minus 4ac divided by 2a. Or plus minus, right? It can be anyone. And this one say is minus b minus plus the opposite of that, b square minus 4ac divided by 2a. These are the two roots. These are the two roots. And this is the value of x, right? Because this is the x-axis right here. And these are the values of x. X equals this and x equals this. Now if you add them, if you add these two values, you'll get the sum x1 plus x2 is equal to minus b upon 2a plus minus b square plus or minus not plus b square minus 4ac divided by 2a minus b over 2a, right, minus plus b square minus 4ac over 2a. So we have just added these values. We have added this to this. What do we get? Well, this and this cancels out because these are opposite signs, right? So we'll get x1 plus x2 equals minus b over 2a times 2. This will be minus b over a. That's the sum of the roots, right? That's it. The sum of the roots is what we got. Now, the sum of the roots represents the roots, the sum of this and this. If we take the average of these roots, we just need to divide by 2, right? Because average is number of quantities divided by total quantities. So the average will be minus b over a divided by 2, which is minus b over 2a. This is the average. Now, if you want to find this average on this x-axis, where will it be? It will be exactly in the middle, right? This plus this upon 2 exactly in the middle. So this value represents this, okay, and this is what? This is minus b over 2a. Similarly, if you remember, if the parabola looks like this, the same thing happens. This average is b over 2a and this is the extreme value right here, and this will be some maximum value for y. So why am I telling you this? we need to find the minimum value of fx. When will the minimum value happen? Well, the minimum value happen at here, b over 2a, right? Okay. So fx equals x square minus 2x minus 3. Find the minimum value. It will happen at x equals minus b over 2a, which is minus b, which is 2, and 2a is nothing but 2. 2 over 2. This is nothing but 1. So if we put the value of x in this equation, we'll get the minimum value of fx. That's it. So we need to find f1. f1 is nothing but 1 squared minus 2 times 1 minus 3. This will be 1 minus 2 minus 3. This is minus 4. Correct answer is option D. Okay. I'll let you review it. I'll check your doubts. Okay. Here's the next question that your time starts. You have 1 minute for this. Okay, that's time. I hope you were able to solve this. If one of the roots of x square plus x plus 8 is equal to 0 is 2, and one of the roots of x square plus x minus b equals 0 is 3, find the ratio b ratio a. So we have one of the roots as 2 of this one, and one of the roots as 3 of this one. So we know the product of root is given by c upon a. So the product of root is 8 upon 1 in this one. So in the first equation, let's call this the first one, and this the second one. In the first equation, the product of the roots is product of roots in 1. The product of root will be given by 8 over 1. Okay. If one of the roots is 2 and the other root we don't know, right? We don't know the other root, but essentially we don't need to know. Let's assume it to be alpha. So alpha plus or alpha times 2 is equal to 8. This means alpha is equal to 4. So the other root is 4. So sum of the roots, what is sum of the roots? Sum of the roots is 4 plus 2, which is 6. And sum of the roots is also equal to minus b over a, right? So minus a over 1. So minus a over 1 is equal to 6. This means a is equal to minus 6. We got the value of a. Now if a is equal to minus 6, let's put it here. So the second equation becomes x square minus 6x minus b equals 0. This is the second equation. One of the roots is 3. The sum is minus 6 over 1, minus of minus 6 over 1, which is 6. So sum is minus 6 over minus of minus 6 over 1, which is 6. One of the roots is given as 3. So 3 plus the other root, which is, let's call it gamma, is equal to 6. So gamma is equal to 6 minus 3, which is 3. This is the other root. So what is the product of roots? The product of roots will simply be 3 times 3, which is 9, right? 3 times 3, which is 9. So Product is given by minus b over 1. So minus b over 1 is equal to 9, or b is equal to minus 9. So we got a is equal to minus 6 and b is equal to minus 9. We need to find b ratio a. So b ratio a is nothing but minus 9 ratio minus 6, which is 3 ratio 2. The correct answer is option B. Okay. So this is, I think this is the last question. Try to solve this one. Okay, the time is up. The coefficient of x in the equation this x square plus ax plus b equals 0 was wrongly written as 8 instead of 1, and the roots so obtained were minus 10 and 2. So you need to understand what was written wrong. What exactly was written wrong? We are told that the coefficient of x, which means this, was written wrong. So this was something else, but they wrote it as 8. It was actually 1. So the equation was x square plus coefficient of x, which was actually 1. So it was x plus coefficient was wrongly written as 8. Now this remains b equals 0. So this was the equation, actual equation, and what they wrote was x square plus 8x plus b. That's what they wrote. Whoever these people were, they wrote this instead of that. And the roots so obtained are minus 10 and 2. So the roots are minus 10 and 2. See, the thing is, although the sum of the roots is different, because you wrote this wrong, right? So the sum of the roots will come out to be different. Some of the roots will come out to be wrong. But the product of the roots will remain correct, right? The product of the roots, which is b over 1, the product, which is b over 1, is still minus 10 times 2. It is still minus 10 times 2, which is still minus 20. The product is minus 20. So we just need to put this value here. So the actual equation would have been x square plus x minus 20 equals 0. This is the actual equation. We just need to find the roots of this, right? That's what we are asked. Find the roots of this. So we can just put minus b, which is minus 1, plus minus b squared, which is minus 1 is 1 squared, which is 1 squared here, minus 4 times 1 times minus 20. Minus 4 times 1 times minus 20 is 80. So this will be plus 80. Divide by 2a, which is 2 times 1, which is 2. This will give us minus 1 plus minus 81. The square root of 81 is 9. Divide by 2. This will be minus 5 and 4. Right? We took plus. We got 9 minus 1, which is 8, divided by 2, which is 4. We take minus. This will be minus 1 minus 9, which is minus 10, divided by 2 is minus 5. The two roots are minus 5 and 4. The correct answer is option B, minus 5 and 4. You can do it by options as well, right? Because if the product of the roots has to be the same as before, which is minus 10 times 2, which is minus 20, then you just need to multiply and see that okay, this is minus 20, this is also minus 20, this is plus 20, this is plus 20. So only B or C can be the answers. But the sum of the roots has to be 1, right? The sum of the roots has to be minus 1, not 1. Because the coefficient of x is 1, then the sum will be minus 1. And therefore minus 5 and 4, which is minus 5 plus 4, this is the only one that satisfies. The correct answer would be option B. Okay, next question. Okay, this one, try to solve this one. Okay, I think that's enough time. If anyone is still solving this, just keep solving it and try to match your answer while you are done. Okay, if you want to watch the solution, just rewatch this video, right? We are running out of time. So how many real solutions are there for this equation? So we have the equation x square plus the modulus of x minus 12 equals 0. We need to find how many real solutions are there for this equation. So as usual, let's write uh, the modulus of x as k. If the modulus of x is k, then the modulus of x whole squared, which is nothing but x squared, will be equal to k squared. That's it. And k has to be greater than or equal to 0 because again, because x modulus is equal to k, x is always greater than or equal to 0, this is always greater than or equal to 0, therefore k has to be always greater than or equal to 0. Now let's write this equation as k squared plus k minus 12 equals 0. Okay, this will give us 12 times, okay, let's apply the quadratic formula, minus c plus minus p squared minus 4ac divided by 2a, k equals. So the two values are k equals minus b, which is minus 1, plus minus b squared. What is b squared? Minus 1 is, or 1 squared, minus 4 times a times c, minus 4 times minus 12, which is 49 or 48 plus 48. This will give us 49. 2 times a is nothing but 1 times 2, which is 2. K equals minus 1 plus minus 1 squared is 1, 48 is 48, 48 plus 1 is 49, 49, the square root of 49 is 7. So this will be 1, minus 1 plus minus 7 divided by 2, or k is equal to minus 1 minus 7 divided by 2 or minus 1 plus 7 divided by 2. This is k equals minus 8 divided by 2, which is minus 4, or 6 divided by 2, which is 3. Now k has to be greater than or equal to 0. So k, this will not be taken. This only will be taken. Right? So k is equal to 3. This means modulus of x is equal to 3. This means x is either minus 3 or plus 3. So how many values of x satisfy this? How many real solutions there are? There are two real solutions, plus 3 and minus 3. Okay, simple enough question. Let's try to do the next one. Okay, I think that's enough time. Let's try to solve this. If the roots of the equation 2x square minus x plus c equals 0 are real and the sum of the cubes of the roots is 1 by 2, then find the value of c. We need to find the value of c. Sum of the cubes of the root is 1 by 2. Now we know that if the roots are, let the roots be alpha and beta. Now if the roots are alpha and beta, let's raise that to the power of 3. Alpha plus beta raised to the power of 3. What is this equal to? We can apply the identity. We'll get alpha plus beta whole cube is equal to alpha cubed plus beta cubed, and what else? Plus 3 alpha beta, alpha plus beta. So this is what we get. Now what is alpha plus beta? Again, alpha plus beta is the sum of the roots. This will be minus of minus 1 divided by 2, which is 1 by 2. And alpha beta is the product of the roots, which is c over 2, right? We can put these values here. We are also told that the sum of the cubes of the roots is 1 by 2. So a cube, alpha cube plus beta cubed is equal to 1 by 2. This is what we are also given. So alpha plus beta whole cubed is 1 by 2 whole cubed equals alpha cube plus beta cube is 1 by 2 plus 3 times alpha beta, which is nothing but 3 times c by 2 times alpha plus beta, which is again 1 by 2. This gives us 1 over 8 equals 1 over 2 plus 3c over 4. Or we can simplify this further. 3c over 4 equals 1 over 8 minus 1 over 2. So 3c over 4 equals, we can take the LCM as 8, or instead write 1 by 2 as 4 by 8. Same thing. Minus 3 over 8. 3 and minus 3 cancel out. This is minus 1, right? And we get c is equal to minus 4 by 8. C is equal to minus 1 by 2. So the correct answer is option A, minus 1 by 2. Okay, I hope that's you got it. I hope that was clear. Let's do the next one. Again, we have the parabola here. I think we discussed enough. I don't think we need to discuss it further. The discriminant, there are values, that is, if there is discriminant turns out to be, say, greater than 0, then the graph will touch the x-axis. If the discriminant is equal to 0, so consider the discriminant. For example, let's take some quadratic equation. Ax square plus bx plus c. So let's take x square plus 3x plus c equals 0. If we want b square minus 4ac is equal to 0, we can have c equals to 9, right? C we can take not 9. Let's take this as 6x. C equals, we can take 9 if this is the case, because 6 6 the 36 minus 4 times a times c, 4 times 1 times 9 will give us 36. If we want b square minus 4ac to be less than 0, then we can take c as anything greater than 9. So we can take 10. 6 6 is 36 minus 40. So c can be 10. Otherwise, we can take c less than 9. 4ac is greater than 0, then we can take c as, say, 7. Right? Let's take these 3 cases. Firstly, a is 1, b is 6, and c is 9. A1, B6, C9. So A1, I think this is not working. Okay, it's fine. So if we take A1, let me draw it here. Again, not coming. Okay, let's draw it here as well. Okay, so consider this is the parabola. If if c is equal to 9, then the parabola will look like this. It will just touch the x-axis. If c is sort of is equal to 10, so that the discriminant is less than 0, then it will go upwards. It will not touch the x-axis. And if it c is equal to 7, then it will touch the x-axis. So in how many places does it touch? Here it does not touch at all. So there are no real solutions here. Here it touches at exactly 1 point, so there is exactly one real solution, and here it touches at exactly 2 points, there are exactly 2 real solutions. So that's the graphical interpretation of the discriminant. Okay, I hope that was clear. I think the time has run out. So let's end the session here. I think the slides are also not loading. So we'll end the session here. Just make sure to take the mocks. Okay, we are providing free mocks at cracku.in. You can click on IIMB UG mock test, and you can go there and you can attempt free mocks. We are also providing you free course material. There you can access the course material as well. Also subscribe to this YouTube channel. There are many other classes going on. Tomorrow there is a session. Day after tomorrow there is also a session. So these sessions will continue going on. So make sure to subscribe to the channel so you can attend these sessions. Okay. Thanks for watching. Thanks for joining in. Have a nice day. Goodbye.